Good evening, everyone, and welcome to another webinar at the National Library of Scotland. My name is Kenny Redpath, and I am the Events Officer at the Library. Just wanted to say that before we start, I had a quick look at our bookings this evening, and not only do we have 118 people booked tonight for this event from the UK, but I just looking at the list, people from USA, Sweden, Italy, Spain, Israel, Belgium, Canada, Germany, France, and Nigeria are all booked in, people from there. So you are all very welcome, even if it is at the moment still into our sitting rooms, the wonders of 1 year on with Zoom. But it's a pleasure to welcome you. It is also my pleasure this evening to introduce Dr. Giles Bergel, who is here to give a talk called Exploring Chapbooks in Scotland with Machine Vision. Giles is a digital humanist based in the Department of Engineering Science at the University of Oxford, where he works for a research group specialising in visual AI. A book historian by training, he has particular interest in applying digital methods to popular printed forms such as broadside ballads and chapbooks, the subject, of course, of today's talk. Giles is also the National Library's first fellowship in digital scholarship, where he was appointed to study chapbook illustrations with the help of machine vision techniques such as visual AI. Before handing over to Giles, can I just say that there will be time for questions at the end of the webinar, so please get thinking and just type your questions into the Q&A function, and we will do our very best to get through as many of those as we can. But for now, over to you, Giles.
Thank you very much, Kenny. I'd also like to thank Rosemary Hall, also at the National Library, who's running the tech today. And I'd like to thank you all for coming, as Kenny said, from various time zones. I'd have, in some ways, very much liked to have been able to present this lecture ending a wonderful year as the National Library of Scotland's first Fellow in Digital Scholarship with the public lecture in person. On the positive side of not being able to do so, you can come and see this from a much wider range of locations, and we're also recording this talk and making it available on YouTube for posterity as well. So there are a number of other people I'd like to acknowledge before we get started. So John Scally, the National Librarian of Scotland, in whose name the fellowship is appointed. Sarah Ames, Digital Scholarship Librarian, who's led the hosting of my fellowship, assisted by numerous other library staff. I won't name all their names, but they've all helped in one way or another. I'd also like to thank my colleague Abhishek Dutta, who's a research software engineer in my group at the University of Oxford. And I'd like to thank Ian Bevan, the great bibliographer of Scottish chapbooks, particularly Scottish chapbook illustrations, from whom I've learned a lot and with whom I'm in close contact during this fellowship. So digital scholarship is very much a team sport, and it relies on community of all sorts of forms of expertise. Now, I'm assuming no knowledge among my audience today of chapbooks, no prior knowledge of chapbooks or machine vision or digital scholarship. Although I know, as you know, that some people in this audience know a lot about one or more of these things. They do, however, mean different things in different contexts and to different people. Perhaps chapbooks, most of all. What is a chapbook? According to the OED, the Oxford English Dictionary, it is a modern name applied by book collectors and others to specimens of the popular literature which is formerly circulated by itinerant dealers or chapmen, consisting chiefly of small pamphlets of popular tales, ballads, tracts, etc. You can clearly hear the caution in this definition, can't you? A modern name applied by book collectors and others. And you can also detect a certain miscellaneous quality in the materials described, small pamphlets, popular tales by the Stretch, etc. Now, the OED is in good company here, according to John Fairley, who catalogued many of the NLS's chapbooks, including the large Lauriston Castle collection, which is the core of the National Library's present collection. According to Fairley, the definition of a chapbook is itself a puzzle difficult to solve. I have not yet fixed it to my satisfaction and possibly never will. And I very much know how he feels. It is, I would contend, much easier to define the chapbook by example than it is by a verbal definition. In other words, showing, defining by showing rather than telling. And thanks to things like the NLS's digital gallery site, which you can see here, it is possible to see chapbooks like never before. There are rare items, and it's perfectly possible never to be able to see them unless you had access to one of the few research libraries or the small numbers in private hands in which they have settled. And seeing what a chapbook is crucial to my method for this project, which is machine vision, defined by Wikipedia this morning as methods used to extract information from an image, which is a rather dry definition. From the perspective of AI, machine vision could be described as teaching computers to see. Extracting information is also, I think, a useful guide to this technology and sidesteps the question of what is AI, a very present debate, which machine vision is very much in the thick of. You might again define machine vision by example as the thing that is done by machine vision researchers, such as my colleagues in the VGG, the Visual Geometry Group in Oxford. We are a large group in the Department of Engineering Science carrying out diverse forms of research and application work broadly in the area of machine or computer vision or visual AI. These terms do overlap. I should say, though, that although I work in the engineering department, I'm not an engineer. As Kenny said in his introduction, I'm a digital humanist. I also consider myself a book historian by training. I come to be in an engineering department because my colleagues do research in this field, machine vision, and release the results of that research in the form of technical math embedded in technical software. And you can see that this is very much technical software from the titles alone. The titles are forbidding and technical, aren't they? But more recently, we've also been releasing more user-friendly software designed for anyone. You can see the names in this case are much more descriptive, intuitive. And my role at VGG includes training and outreach with this software, which is freely available. Everything I'm going to show today, with one or two exceptions, is free and open source, and those exceptions will be free and open source by the time this project winds down altogether. So, like I say, my role includes training and outreach to the software, but also serving as something like a guinea pig for its development. The idea being that if I, a non-engineer, can use it, so might others of my kind. What is digital scholarship? The principle of engagement that I just outlined with my research group's agenda dovetails really excellently well with digital scholarship in cultural heritage organisations like the National Library. And I borrowed this graphical definition of digital scholarship from Sarah Ames, who I've mentioned as my host, if you like, the digital scholarship librarian. And Sarah positions digital scholarship as at the intersection of collections, research, and computational methods. To that end, the NLS maintains a data foundry, a collection of open curated data sets. And here are some of them. These all look slightly similar in this slide here, but they're actually diverse. And there's actually also a much bigger range of them than this slide shows. But in this view, you can see it includes Chapbooks, for instance, Scotland at the bottom there, which is a set of over 3,000 digitized chapbooks, images, metadata about those images, and OCR of their text. Really available and packaged, zipped up in a way that makes them extremely easy and very convenient to use in a digital scholarship project like mine. And you know, it's no small feat to put data sets like these together. It's a lot of work in itself, and also it's a very generous gesture. It requires storage space and bandwidth so to do, and it relies on a lot of work that's gone before, of course, in libraries. Generations of curatorship, conservation, imaging, cataloguing, and all the other things that public libraries do to make their holdings available, whether it's in digital or original form. And I'm certainly keen that digital scholarship work doesn't overlook that work overlook that prior work. It doesn't, if you like, see itself as purely a takeaway from the library, but it is mindful of how it's come to benefit from that work. So my interest in the data set, at least for this project, is primarily for the Chapbook illustrations. There's also been very good work done prior to my project on the Chapbook text, the OCR text, and more will no doubt follow. The illustrations, as many commentators have said, excuse me, as many commentators have said, it was often felt necessary to ornament the front cover of the Chapbook with a picture, and a woodcut usually served this purpose. It's fairly crudely executed and made only an indirect allusion, if any at all, to the content. This comes from an edited collection of Chapbook text and images by Ted Cowan and Mike Patterson, unfortunately out of print. And on the right is my example earlier I was showing on the Data Foundry site. Probably the kind of thing the authors had in mind. The front cover, it's on the front cover, as they say. So it's on the part of the book that is most public facing, of course, that advertises the Chapbook. And it is, as they say, a woodcut illustration. Woodcuts are illustrations printed from wood blocks. On the left here, you can see a Newcastle printed religious chapbook of the mid-18th century, together with a rare original woodblock now in the British Museum, which is imaged with, in this little movie here, it's been imaged with a technology called RTI, reflectance transformation imaging. It's a wonderful technique which produces a high resolution virtual panorama of an object. And just kind of start that over again. It's good for exploring the details of this block's manufacture. You can really see the tool marks, the grain of the wood. And this block manufacturer is actually quite careful, not crude. This is a kind of virtual lighting mode, which really helps, doesn't it, in seeing all the details, the crannies. Like I say, this block is quite carefully made, I think, and very much the purpose for which it's intended. And I'll say more about that later. So, my research questions on this project then. What was the stock of blocks used by Scottish Chapbook printers? What images were made available to Scottish Chapbook readers from particular locations? And can we use visual AI to classify the content of the illustrations? The steps and methods that I adopted for this work are: 1, to find the illustrations using an object detection algorithm; 2, match the illustrations by their visual features and add them with metadata, printer, place of publication, and other terms, to a database; and 3, classify the subjects or content of the illustrations with deep learning. And I'll explain what all those methods are and how they're being used in this project to these ends. So, object detection, first of all, in order to find the illustration. Object detection, a common machine vision task. It consists of both identifying and locating things, cars or pedestrians. So it's both image classification, it's both understanding that there is a car, there is a truck, there is a person, umbrella, things in an image, but also localizing them, detecting the boundaries of them and displaying those boundaries in the form of these annotations, these colored bounding boxes with a label on the left here. On the right, you can see a paper that introduced a new object detection algorithm released last year, which we adopted for this project. So we used efficient det, released by Google, and announced in a paper which I can't understand. I'm not an engineer, it's a highly technical paper. I do understand rather better the image on the left and see what's intended here. And you can see there's also a graph, announcing boasting the high performance of efficient det against other detectors that are out there. And my machine vision engineers love producing these kind of comparative bake-offs. And a major part of the work of machine vision is creating benchmarkable data models and data with which to do the benchmarking. Okay, so we used efficient det. We also used this software, VGG LISA, which stands for list annotation. And this was created for this project, but it also has other purposes by my colleague Abhishek Dutta. And what you can see here is the user interface. It runs in a web browser, and it allows you to scroll through a list of Chapbook images and annotate them. So here, Abhishek is annotating the illustrations. The woodcut illustration, the little bounding box. And you can also resize them. If you make a mistake, you want to make the boundaries different, you can delete them and draw again. And it is in general a extremely convenient, nifty little tool for kind of data entry. Now, data entry is a step within any kind of digital activity, and data entry, data cleanup, getting data in the first place are steps that are often underestimated. Like I say, the National Library has saved me a lot of trouble by zipping images together with very good metadata. Similarly, this tool here, Lisa, although it's not as kind of impressive seeming as the object detection algorithm, is nonetheless vital for kind of creating data for the purposes of training, actually. So this is the first step in the workflow, which is training the object detection algorithm or network with some images of the things that I'm interested in, illustrations. So this is an overview. This is an overview of the process we went through. First of all, Abhishek, when he wrote this tool, then he manually annotated 337 chapbook pages in Lisa, which took about an hour, I believe. Then he trains the efficient debt network with those images and said to it, so to speak, go and look for the same kinds of thing in 20,000 images. Then it was over to me, so he handed me back the Lisa tool with those annotations present in them. So I scrolled through those 20,000 images, looking for those illustrations, reviewing and revising just over 1,600 predicted annotations in Lisa. And it sounds like a lot of work, but really it was made very convenient by this tool. It took me, a couple of days. It was not onerous. It was very intuitive, and I crunched through them fairly quickly. Then we retrained the detector with the revised annotations and applied it to the rest of the images to see if the performance could be improved, and it was. And I reviewed and revised them again, and as a result, we extracted 308, we found 3,864 illustrations on just over 3,600 pages. And it was in general extremely accurate. So these are all detected illustrations. These aren't drawn by an individual. These are detections, and there are some absences here. So you can see on these little playing card illustrations here, some of them haven't been picked up for slightly mysterious reasons. Actually, these kind of deep learning methods are notoriously hard to kind of break down. It may be that the illustrations are too close together, too close to the text, but not all of them got picked up. So this is the value of what AI researchers call human-in-the-loop supervision, of having a human, me, who knows what they're looking for, to kind of supervise and retrain. It's not all about, a black box in the corner doing it all without any supervision, or if it is, it's unlikely to be extremely well performing with current technologies. You need to review, you need to revise, you need to find and any false negatives and add them back in, which I did. And you also have to delete false positives, which there are more, and they were fascinating actually for what they told you about what the detector was thinking, quote unquote. It wasn't actually thinking, but what it thought I was interested in. So here you can see an illustration that is actually on the left. There's bled through from the page on the right. So it's on the other side of, it's on the verso of that page. And you can understand why this is something the detector thought was relevant. It wasn't, I just deleted it, it wasn't a problem. There are also, things like library stamps were flagged up, and very interestingly, marginalia. So things that are kind of outside the regular run-of-the-mill page throw the detector, which is quite thought-provoking. And marginalia is a major area of interest in book history at the moment. So it's certainly possible. One can imagine positively trying to find marginalia using this technique. And I know that there are some research projects that are looking at that right now. Okay, so ruling those out and adding all those up together, what resulted was a browsable database of illustrated pages. So I took the pages that had annotations, that had illustrations on them, and added them to a database with the metadata. And the metadata, being as it comes from a library, is very well regularized. It's attached to external authorities. So, I can browse by place of publication. I can browse by printer, publisher, and other features as well. So it's possible to browse all the illustrations of chapbooks printed by the very large firm of J.M. Robertson in Glasgow in the late 18th and early 19th century. These are really distinctive, the Robertson firm's chapbooks. And, you know, the woodcuts aren't crude, I would argue. You be the judge. I don't think so. Perhaps these kinds of things, so work of Moran's printing house in Edinburgh and roughly contemporarily, are closer to what critics of chapbook illustration have in mind, or those from printed in Falkirk by Thomas Johnston and others. There's a veritable dynasty of Falkirk chapbook printers, and they publish for others as well. These are certainly simpler illustrations. Are they cruder? I don't know. I mean, I think in a sense they are optimized, they're fit for their market and their function. There's a great anecdote from James Lumsdon, who is a Glaswegian chapbook printer, to Thomas Buick, who's, if you don't know Buick, a very productive, famous and high quality producer. He's a revolutionary in the history of British illustration. And he did fine work, and he also printed for all kinds of purposes. He received this complaint from Lumsdon that I received yesterday a number of cuts and coincides an opinion with you that they're done in a very slightly ungrammatical there. This is a literal transliteration. I coincide in opinion with you that they are done in a very superior manner, but the style is very far from what I expressed to you, and I'm extremely sorry to say are useless for the purpose intended, as no person here can do them justice in printing. I shall forward by some opportunity these received, so you may make them a little opener in the style. It would be useless to put them to press in the present state, as the coarseness of the paper we use would quite destroy them. Now, what does this mean? Now, these are popular items. These are cheap print, like costing a penny, a halfpenny, maybe, you know, at most tuppence for the more longer and more elaborate ones. Therefore, that in order to hit that price point, they are printed on, it is true, kind of remarkably cheap paper sometimes. I mean, the kind of chapbook papers I've seen, I know Ian Bevan, my collaborator, has seen some extraordinary looking yellowish brown papers that, you know, quite similar possibly to papers used for commercial packaging. They're absolutely trying to hit that low price point to reach a popular audience, and so the illustrations are required to be to fit that task, to fit that purpose. This isn't crude. This is specifically directed towards that function. And there are other things that influence the quality of the impression as well. The fineness of the impression, the ink, the press work, and the presses themselves. And there are advances in all of those things throughout, in particular from the mid-19th century on, and you can see that as well in these work from in Glasgow and elsewhere. You can see kind of what is achievable at a certain price point is not static. You know, chapbooks are as much a dynamic entity actually, although they're often considered to be wholly traditional and rather conservative, but they do respond to technology. They respond to market pressure and readers' demands and innovation in technology and in art. Okay. Now, some chapbooks in the NLS data set, I mean quite a few, and I haven't added them all up yet, do not have the name of a printer. They may or may not also have a place of publication. So this gallery I've retrieved from my database says only entered according to order on them, where you would expect there to be the name of a printer, such as Lumsdon or Robertson, in a place of publication or printing. Those things are different, actually, of course. It says, so entered according to order. This is a phrase derived from the practice of entering titles of works in the Stationers' Register, the Register of the Stationers' Company of London, to establish a legal claim to copyright. This is the mechanism by which copyrights in the United Kingdom is asserted from between 1710 and 1922. Everybody who wants to claim copyright in something has to take their work, or at any rate the name of their work, to Stationers' Hall in London and enter it for a fee in this book. and then they're entitled to say that their book has been entered according to order. They also, commercial artwork is, and prints and music is also entered in this way. Now, I and David Atkinson and others have done some work on this. I seriously doubt that many chapbooks were actually registered in this way. Certainly I haven't seen any entries in the stations registers, which is still extant and it's digitally available, although paywalled. Some of it is the earlier part you can browse, but for this period you have to go through a commercial website. And I've never seen a chapbook entered in the stations register of this date, certainly. So I think that this phrase is misleading, or at any rate it's not accurate. And the work that it's doing is kind of slightly hard to kind of comprehend. It is in part, I think, customary that you see this phrase entered according to order on earlier work, which was entered in the stations register. It's partly, I think, a warning to other printers, publishers, not to infringe if you like, a customary copyright, to say that actually, you know, that the printer or publisher does care about the contents of the work. Primarily, though, overwhelmingly, I think it's to protect, and we know this actually in some cases, it's there to hide the source of the item, so that, particularly in remote locations far from towns and cities where chapbooks were printed, so that purchasers could only get other chapbooks, other titles from the chapman or their local agents, you know, which could be a general purpose retailer, particularly a pharmacist. There's a close relationship between cheap printing pharmacists and general stores at this time. So that's my supposition. You know, that certainly there are other possibilities, but that's probably what this is doing. It does raise a question, which is, where were these books entered according to order actually printed? This can be addressed. This is part of the motivation. Addressing this is part of the motivation for my step 2 in this research, which is matching the illustrations. So it's a different technology from the detection of illustrations. This is matching, finding things that are the same, features that are the same for some value of the same within images. So on the left is a screenshot of the cover page of a piece of software called Vice, or Vise, VGG Image Search Engine, which we maintain, and it's freely available now. There'll be new versions coming soon for Windows, Mac and Linux. There is a version that's downloadable right now, but the version I've been using is a bit newer. That will be out shortly. And what it does, you can see an example of my right, is find matching features in this case, buildings in Oxford. So there's a well-known computer vision training set, benchmarking set called Oxford Buildings, which was created by us, actually, my colleagues in VGG, to benchmark and advance computer vision methods. And these little red ellipsoids joined by are joined by these green lines here are indicative of matching features, which are formed from transitions in texture or contrast around an image. And you can see here, this is pretty good at retrieving this image, even though the scale is different and the angle of view is different. Which just makes this feature quite nice for certain classes of real-world objects. And it is particularly useful for things like woodcuts. So here's my database, which integrates a visual search function. If I can just press this, you can see here it's entered according to order. And to make it work, I select a region of the page, as in Lisa. I press search and it retrieves visual matches. I see one of them immediately has a more descriptive imprint. If I select more, I can see things that do match and one or two things that don't. I think I might just go back on that because that might be it might be interesting to see what it can do and what its threshold of accuracy is. So the low scoring features are relevant. Below that, we have features that aren't relevant. Now that's to be expected in that a system like this always tries to be helpful. It always tries to, find matching features and present them to you in a way that is oblivious of context. It doesn't understand any of the semantic content of the images, but it does say that, it's not incorrect to say that the things that it's retrieved contain the features that you're looking for. It's just that the thing you're looking for turns out not to be relevant. We can improve the performance. We can tune out the kind of low end of these results by using more data and more finer grained methods, but it's at least as good enough. It is good enough, as you can see, to find matches for this list here on this entered according to order chapbook, which I see from the matches an illustration printed by Robertson in Glasgow. But this has already been noted actually by librarians at the NLS. So the place printed Glasgow has been filled out. This is the library's own metadata. And in truth, it's not hard to tell a Robertson chapbook. So there is prior work here that's going on. And there's other prior work you can see elsewhere in the library's collection. So this entered according to order chapbook, which different one has the pencil annotation, Glasgow, J&N, Robertson under the principle, I imagine, that I've just noted. So recognizing the woodcut, perhaps also the page layout as well, but particularly the woodcut. Now, I've asked people in the library, Annette Hagen, who asked colleagues of hers who made that annotation, and they think that it's John Fairley, the bibliographer, who did a lot of work cataloguing the original collection. So there's a kind of nice kind of lineage here for me to see that others have gone this way before, that there is this act of recognizing imprints, place of publication by the block has a history to it. More prior work exists in the scholarship of Ian Bevan, who shows here matching blocks on these two chapbooks. The one on left printed, and you probably can't see that very clearly on the screen. It says printed for and sold by the publisher Inveraray. It's in Gaelic, isn't it? On the right, we see the same block within chapbook again, printed by J&M Robertson in Glasgow. Now, the one on the left it's not false as such, it's simply incomplete. So it's printed for and sold by the publisher in Inveraray. So the publisher in Inveraray, James Chalmers, is acting as the distributor of work produced to order, commissions, custom work from Glasgow. It's long been known that these blocks are reused. Here, for example, there's a block on the move again from Chalmers' press, Aberdeen to Peterhead. And I know it's the same block because I have this visualization here, which my database also supports, with the two woodcuts layered on top of each other. There are some variations in inking, and there's a little bit of distortion, which you would expect results from the variable accuracy of different impressions, possibly also photography introduces distortions. And there are ways also in computer vision of accounting for those discrepancies, so we can register and allow this kind of comparison and difference detection, which could be automated, but here it's simply a comparator tool that's showing you that this is the same block. And this is relevant because blocks can be copied in some cases really rather accurately. So here's an example of two blocks, one in Stirling, one in Glasgow. If you look at these side by side, you might miss the details, but if you look at the sword on the left, for example, I'll just play that again, or the plumes of the helmets, you can see clearly that this isn't the same block, but it is a pretty close copy. They can make very good copies by, for example, pasting an illustration, the paper face down on a wood block. Then that you can apply oil or some kind of varnish solvent to the illustration, allowing the background to show through. The background will become lighter in color, and then you just chisel away, cut away with a knife or other tools at the white space, leaving your impression ready for printing. Okay, moving on. I've seen through the visual matching in the database also blocks assembled in multiple combinations. It's got a nice example on the top left. You've got kind of back to front soldiers who are performing different configurations throughout this collection, sometimes different blocks. These are the sorts of things that throw the classifier and thinking that these are separate blocks, but you can see, for example, the one on the bottom left, there's a gap between the two of them, which makes it easier to see that they're actually different pieces of wood assembled in the same composition. You can also see blocks that have been cut up, that have been shaved. I'll just click that through again. That's a really nice registration, which allows me to see immediately that this really is the same depth. There are some variations in the impression, and you can see that the paper is quite different here. And I'm pretty sure this is either the same block or a very, very close copy. But this is a form of AI that is, if you like, a pair of glasses rather than a brain, an abstracted intelligence. You know, AI is as an aid to vision and an aid to judgment, rather than a decision-making mechanism, a black box that's outside of the human in the loop. Okay, so here's a particularly interesting example, a block staying in one place for over 50 years. You can see that from the typography in the paper, this one on the right is considerably more modern than this one on the left, but the block remains. And so again, it's a nice registration. I can see from the crack, and these areas of damage are quite useful for verifying whether they're the same block or not. And it's really in quite good condition after a long period of time. There's an anecdote about the masthead of a Newcastle newspaper that was used for probably about the same length of time. And the printer John White reckoned that it served up well over 1 million impressions. These are quite hard-wearing surfaces, they're hard-working surfaces. Okay, now I have to kind of caveat this this game of block matching by saying that, by pointing out there is the technology of stereotype, which becomes important in chapbook printing, certainly in the mid-19th century, and may have been used earlier. So stereotyping is a process of image reproduction from which we get the term stereotype, which involves casting in metal the reverse of an illustration. And we have a nice anecdote about the process from John Urey, who worked for Nielsen, a Paisley printer of chapbooks. His reports, having started his apprenticeship as a stereotyper, having spent some time in London learning wood engraving. And in those days, we stereotyped by pouring liquid stucco, and plaster of Paris is sometimes used, of the face of the type and allowing it to harden. Then we took the stucco mold off and poured melted metal over it. And from that, you get a thin metal shell. And you can, if you like, stereotype that again, and it reverses the impression that you've got, leaving it the same as the one that you've molded. Stucco is used in this case. Later on, they use plaster of Paris, also known as flong. And here, it's not just the illustration, but the entire page is being stereotyped. Now, I don't know if any of these Nielsen chapbooks printed in Paisley on the right are stereotypes. The association with Urey would make that interesting. Some of them do look, you know, in suspiciously good condition. Certainly, a little later in the 19th century, one sees whole series of stereotyped chapbooks from Glasgow. So this is part of a series printed for the booksellers, a numbered series from the press of Francis Orr, which contains particularly literary works, or religious works, histories. These are getting to be quite elaborate publications now. And they do have a look, a kind of certain kind of uniformity, a greyness that's I kind of imagine is, to myself, is characteristic of stereotype, but really it's extremely difficult to tell. It's an area of active research. Ian and others are involved in Bevan, and it's to be hoped that we can improve this over time. What we have now is very direct evidence in the form of these markings on these two illustrations here. So you can see on the one on the left, there are some white spots here which are made by screws. So this is from the metal plate, the stereotype plate has been screwed into a wood block on this very indistinct chapbook illustration here. Similarly, the one on the right. Now, I've seen variants of this swan image in dozens of places, particularly I've seen it in Newcastle. Although the blocks tend not to move very far, the subject of the illustrations do move around. This swan figure is a standard motif, and you can see these black marks here, which are nail holes, Ian and I reckon, as similar again from a metal plate, a thin metal plate, which later on in the century could have been made. So where are we, 1829? I want to say that by the end of the 1830s, or perhaps early on, we have a process called electrotyping, which makes a much finer quality copy of the book. And you would imagine a material like this, it would have been used widely. You would imagine that it's a useful technique for this, this class of material. Okay, moving on to my step 3, classifying the content of the illustrations. Now, this isn't hunt the block. This is describe the content, describe the subject. And here's an example of a demo we host at VGG's website, a collaboration we did with the organisation Art UK, in which we detect the content of these paintings. So you can maybe see the text boat in the search box here, from which a classifier has retrieved images tagged with boat, and then fairly successfully retrieved boat-shaped objects from a corpus of British art. Originally, this is the Your Paintings dataset, which is paintings in public ownership in Britain. This is done with this software, which incorporates, incorporates a CNN, a convolutional neural network, which is the technology that has been most responsible for the advances in image recognition that have seen, in the best of circumstances, visual AI systems being able to retrieve cats or dogs. Now, how do we do this? There's 3 steps. First of all, we select a suitable untrained neural network model, and then we feed it images, labeled images of the things we want it to find, so cats or dogs. We don't tell the network anything else about them. It knows nothing else about them. All it knows is that the things it sees has this label. And then it's, if you like, over to the network to figure out the features within the image that corresponds to that label. That's the training stage, and inference stage is setting it loose on images it hasn't seen before. So I've been just very recently experimenting with this with the Chapbook illustration. So for example, I've been tried looking for printers ornaments, these little small decorative printers devices. And these are my training images. So I took a neural network that had been trained on very large numbers of generic images, been trained on the ImageNet database, hadn't specifically been trained on printing devices. But then I gave it a subsequent training set, some examples, these ornaments here, and the results are not terrible, not perfect. So in my top row, the top 4, yes, those are printed ornaments. The one immediately to the right of it, no, that's not. That's some kind of scenery there's a kind of mixed portrait picture as you go down, which gets more mixed. So there are some things that are certainly not. There's this Adam and Eve being expelled from Eden here, coats of arms. On the other hand, so although this isn't perfect, on the other hand, you can kind of see the classifier's points, if you like, that, you know, these things are somewhat similar, and they're quite thought-provoking and quite actually quite useful for kind of serendipitously searching the collection. It could be, this could be improved by more examples and kind of finer grained classification, but it's not going to replace certainly any kind of human supervised or human enacted cataloging process any soon. But it's an active, it's somewhere to start from, I think. I had a bit more luck finding sailing ships. So the training images for this were a fairly random collection, so I don't have examples of them, of ship images from Google Images. And the top 2 rows are all correct. If we go to row 3 was correct. That is not a sailing ship. That is not a sailing ship. That's a woman in, I'm pretty sure that is, maybe it's either a sailing, that is not, I'm recalling that now. I think that's from a chapbook illustrator who worked for James Moran. That's a woman in a dress. But again, you can kind of see what the classifier is thinking. And as you go further down, there's some things that actually it rules out. So this yellow triangle means not a sailing ship. But there are some features that slightly resemble those shown earlier. My most great success with this material was looking for portraits. Those are all pretty much accurate. And again, those are trained from just generic photographs, actually, of portraits grabbed from Google. Okay, so that is where I am up to. Digital scholarship is an ongoing and iterative process like Chapbook research. So there are some next steps, although the fellowship is very happily, very very successfully, I think that unhappily, sadly, come to an end. There will be some next steps which include releasing the software that hasn't already been released that I've used in this collaboration. So our Vice and Vic tools, you can get them now. They're under development and they will be improved, entirely free. And we have support mechanisms available for feature requests, bug reports. The LISA tool and our efficient debt model are likewise going to be released shortly. Data is also forthcoming in the form of the annotated page images, so the images with the annotations. And this is going to be, I think, very interesting and very useful for people looking for illustrations in other forms of printed material, other documents, because the ground-truthed annotated images can be used to benchmark new methods. There are already some document analysis of some page layout classification data sets available, and it'd be really good to see Chapbooks joining them as a distinctive, important form of printing. And, you know, I make this point in part because I'm very keen that digital scholarship be seen as a virtuous circle rather than a one-way street, that it's an iterative process that aims to give something back to the community as a whole, including possibly in the form of visually matched regions and subsequently preliminary identified printers and places of publication. So I've shown a couple of examples of printers identified or places of publication identified. There are others. I don't have time to show all of them. Some of them have previously been known and noted in the catalogue, others haven't. There's also one or two illustrations that come from elsewhere than the United Kingdom. So that will all be made freely available and will be, I expect, annotated by others and taken on by others, as well as improved work done by myself. Accompanying data release and software, there's going to be a technical publication, and I hope also one that's more from the perspective of chapbook culture and book history, and of course further research on blocks and their subjects.